In this video, we're going to look at security in AWS from a bigger picture point of view. We'll first step back and look at how security traditionally works, and then see how that changes when you move into the cloud. In traditional on-premises environments, your company owns or rents physical servers, racks, and network gear. Your security team is responsible for protecting everything, from the data center doors all the way to the applications. In the cloud, you don't own the physical infrastructure, and that naturally raises an important question. Where does the cloud provider's responsibility end, and where does yours begin? At a simple level, security in the cloud always comes back to two questions. Who can access your AWS resources or applications, and what are they allowed to do once they get in? Think of a small online store running on AWS. Customers should be able to sign up, log in, and place orders, but they should never be able to see other customers' data or change pricing. In AWS, you're protecting many different things: databases, storage buckets, compute resources, your management console, and the application exposed to the internet. Different users and systems need different levels of access. AWS uses a specific model to define security responsibilities, and that's called Shared Responsibility Model. This is one of the most important concepts in AWS security, and the model explains which part of security AWS handles and which parts are your responsibility as the customer. At a high level, AWS is responsible for securing the underlying cloud infrastructure, and you are responsible for securing what you build and configure on top of it. You'll often hear this summarized as AWS is responsible for security off the cloud, and you're responsible for security in the cloud. Now, security off the cloud includes AWS's data centers, physical hardware, networking equipment, and the core services that run AWS. And security in the cloud is everything you configure and control. For example, who can log into your account, how IAM permissions are set, whether storage is encrypted or not, and how your application handles sensitive data. If a storage bucket is left public by mistake, that's usually not an AWS failure. It's customers' configuration issues. Understanding this model is critical, but you also need practical guidance on how to apply it. And that's where AWS's Well-Architected Framework comes in. As you may already watched our previous videos about AWS Well-Architected Framework, you may already know that security is one of the key pillars of this framework. Security is a set of best practices for designing and running workloads in the cloud, and it focuses on protecting your data, systems, and supporting resources. Now let's walk through a few core security areas where you should be familiar with. The first one is Identity and Access Management, or IAM. IAM controls who can do what in your AWS environment. You define users, groups, roles, and assign permissions to them. The most important principle here is going with the least privilege. If you remember the POLP, or principle of least privilege, you should be familiar with the idea of only granting the minimal access needed to perform a task. The second area is data protection and encryption. This covers how data is stored and how it moves. You'll hear two common terms in here: data at rest, which points to data that is stored in databases or storage services, and data in transit, which points to the data that is moving across the network. AWS provides tools to encrypt both, such as enabling encryption on S3 buckets, EBS volumes, snapshots, RDS volumes, and using HTTPS for secure communication. The next area is network security. Network security controls how traffic flows in and out of your resources. In AWS, this typically involves VPCs, subnets, security groups, and network ACLs. For example, you might allow public access to a load balancer while keeping databases in private subnets. The next area is application security. Even with strong IAM and network controls, vulnerabilities in application code can still expose data. And application security focuses on how your software behaves. AWS services like Web Application Firewall, or WAF, help block common web-based attacks. The next area is compliance and governance. Compliance means meeting regulatory, legal, and internal policy requirements. AWS provides compliance certifications for its infrastructure, but it's still your responsibility to configure services in a compliant way, such as enforcing encryption or restricting data to specific regions. We covered this topic in details with good examples in our previous videos when we talked about AWS Config and AWS Audit Manager service. And the last area is managing your security ecosystem. Since security is ongoing, this area focuses on monitoring, logging, and responding to issues. In AWS, services like CloudTrail and CloudWatch help you track activity and detect unusual behavior whenever they happen. Okay, let's summarize the keynotes you should remember from this video at this stage. The first key concept to remember is the shared responsibility model. You should remember that moving to AWS doesn't remove security responsibilities, it shifts them. Think about the security pillar in AWS Well-Architected Framework. AWS is responsible for security of the cloud, including data centers, hardware, and the underlying infrastructure, and you are responsible for security in the cloud, covering access control, configurations, and how your data and applications are protected. AWS secures the foundation, but you secure what you build on top of it. And misconfigurations and customer-managed resources fall under security in the cloud. And that is it for this video. Thank you so much everyone for watching. Please make sure you're subscribed to our YouTube channel, and I'll see you in the next video.